Good morning and welcome to today's News on the Block Knowledge Bank, a PM's guide to net zero, delivering efficiency and carbon savings for your residents. This is presented today by Paul Martin and Christian Koch of Data Energy. Now, with the climate crisis is now a global concern, everyone's becoming increasingly mindful of their own environmental impacts. So today, our experts are going to be discussing energy efficiency and the UK's net zero commitments and how you as property managers can deliver energy efficiency and carbon savings for residents. Now, the presenters today are really looking forward to receiving your questions. So please use the Q&A button or the chat function at the bottom, and we will answer all or as many of your questions as we can. So I'm going to hand straight over to Martin and Paul. Good morning.
Good morning. So very warm welcome also from our end again, from Data Energy myself. I work as a consulting energy engineer for a energy services company, Data Energy, and my colleague Paul as operational manager. The thing we kind of want to go through today, can we move? Yeah, we just want to give you as the managing agent really good guidance of what you can expect over the next probably 20-30 years, but even almost for tomorrow, things that are applicable and that are required to be delivered to bring your buildings to net zero, to zero carbon emissions. So we've got this Q&A session. What we're going to cover, my colleague Paul will start. He's going to set the scene and talk about what the net zero target is and why we really have it. So that might be common ground for many of you. And then he's going to talk broadly about how to reach this target. And then we have a little Q&A section about probably half past the hour. And there's the time for you to kind of ask us any questions you want. And the second section I will take over then, where I go into more details, in particular how to decarbonize heat, which is going to be a difficult topic, but is very relevant for you as property managers. And many of the duties that come down from freeholders and from the RMC, they kind of they are about heating systems and about the building and thermal performance. And I will also give you really practical tips where the regulation currently asks you things to do, so where you're obliged to do things, and then some best practice information. But now I will hand over to my colleague Paul.
Morning all, hope we're all well. Right, let's kick off. You've all heard of net zero. It's been about in the press, huge amounts. Do we actually know exactly what it means? Simply put, it's net zero refers to the balance between the amount of greenhouse gas we produce and the amount we remove from the atmosphere. So to reach net zero, it's when we get to that stage where the amount we're adding is no more than what we're taking away. We need to decarbonise almost every single building in the UK, if we think about it. That's 100% of the UK building stock. We've got circa 30 million homes in the UK, and we've got 30 years to decarbonise. That's 1 million homes a year. That's a lot of work to do. I mean, we've made huge steps up to now. I mean, the electricity grid has decarbonised incredibly. We've got a saving of over 72% on emissions just from electrical generation in the last couple of years, 10 years. It's been fantastic. So what's happened is we've increased the renewable capacity to the grid. So we've got more wind turbines, more solar power added. So to build on this success, what's happened in the end of last year, Boris Johnson came up with a 10-point plan. And he called it the Green Industrial Revolution. Now, of these 10 points, very few actually refer to yourselves as property managers, but there's probably 3 in there that actually do. The first one that applies to you guys is make homes greener, warmer, more energy efficient. The second is probably the electricity you're using within these homes that you're managing. This needs to be clean electricity. Obviously, the grid's decarbonising, but you can look at other areas, whether you install your own PV or your own wind turbines. And then the big one that may affect you is electric vehicles. So if we go on to the first one, make homes greener, how are you going to actually do that? Obviously, Christian will go into more detail, but you're going to need to do and look at every single thing within your buildings, and then how you can look to better their energy efficiency or even replace them. When it comes to wind, as I said a moment ago, can you introduce your own wind turbines? Can you introduce your own PV? How are you going to supply clean electricity to your buildings? And then when it comes and moves on to electric vehicles have increased hugely. If you look at the figures for 2015, we sold about 9,500, 10,000. And then you go to 2020, we're now at 108,000. That's almost a 12-fold increase. So the amount of charging points you're going to need on your properties in the years to come is probably going to be 100% for every parking space. If you think about it, in 2030, there's no more new sales of petrol or diesel powered vehicles. So where are they going to charge these? You've also got to look at how are you going to meter that? How are you going to charge your residents for charging their vehicles? Have you got the capacity, electrical capacity within your buildings to supply that amount of electricity? There's a lot involved and a lot to be thought about going forward. So when we look at a building, there's two sorts of carbon there. The white paper described the two types. We've got embodied carbon and operational carbon. Now, embodied carbon, there's very little really you can do about this. This is the emissions that's arisen through the actual building of the property. And when they define this from cradle to grave. So if you look at a piece of wood within your building, they will look at the carbon footprint of that piece of wood from when it was grown, transported to manufacture, manufactured, transported to site and installed. So they take it right from start to finish, and that carbon footprint you'll never be able to change because it's there, it's your building. But the operational carbon, this is important to you because you can affect that. This is the day-to-day carbon that your buildings are giving out through the use of energy. So you can improve this day by day, month by month, year by year. But how do you go about actually doing that? How do you reduce your operational carbon? Well, the buildings are going to help you or not help you. If you've got a building from, like my home, 1903, there's a lot of work involved to get a 1903 house carbon neutral. But if you've got a brand new building, perhaps built by under passive house guidelines, that's going to be close to being net zero already. So where's operational carbon saved? You've got to use less energy. Now, this might be through residential education, get them to turn their lights off, not leave their televisions on standby, etc. But also that energy you're supplying to the building, you've got to supply it efficiently. So you've got to look at, let's look at your insulation throughout the building. Have you got hot water pipes? How well insulated are they? What is the tap temperature that the residents, when they turn their tap on, is it 50 degrees, 55 degrees hot water? Can they look to reduce that temperature? And then perhaps look at how you're supplying your building with energy. Can you use any form of renewable energy, such as heat pumps? The Carbon Trust has done a big thing on heat pumps and thinks they're the way forward and the future. So perhaps you could look at heat pumps, or even, again, PV on the roofs, maybe a little wind turbine up there. Even if you're only generating for your communal areas, it's a saving. The other one, which the government's pressing in the UK at the moment, we've got about 2% of the population connected to a district or communal heating scheme. The government's looking to take that to 18% of the population. So perhaps your buildings are in an area where there's a district heating scheme. Perhaps you can look to connect to that. There's lots of options out there. It just depends on the building in particular, where it is, the age of it. You've just got to look at it and move forward. The challenge for you guys is you're going to have to get to know your buildings. Perhaps you should be carrying out energy audits on your actual building. I know Christian will go into this a little bit further and a little bit deeper later on. But unless you meter your building, monitor your building, how can you actually manage it? If you don't know where the energy is going, how can you reduce it? So you're going to have to take some time, and you're going to have to get to know each of your buildings, and at different times during the day. Have you got high energy usage during the night? Why have you got high energy usage during the night? So you need to meter it. It may be every 15 minutes or every half an hour. Once you've done that, you can monitor it, and then you can start to manage it. And once you've identified where you're losing your energy or where you can make savings, you're going to have to prioritize it, because obviously money's a factor, the actual carbon savings a factor. And once you've got your priorities, then you can make your changes. The problem in the UK, buildings are the second largest source of emissions. That's the second largest source. That's incredible. So there's so much work to be done. If you look at that other figure there, energy performance certificate D or worse, that's 66% of our homes. But that's not surprising when you look at our homes. A lot of our homes are turn of the century, or if not older. I mean, as I say, mine's 1903. A lot of the old terraced houses are all around the Victorian Edwardian times. How do you make them net zero? A lot of work. And presently, 90% of homes in the UK use a fossil fuel for either heating, hot water, or for cooking. 90% use fossil fuels. How are we going to get that down? Big question, hard work. So that's just a brief overview for me about what we're going to be talking to. As I say, Christian's going to go into far more depth. If you've got any questions you want to bounce in now before we go into more depth, please use the chat function and fire them across. I don't suppose there is many. That was just an introduction, but please, if you've got any.
So we've just, there isn't anything in the chat, but please use the time now. If you have any questions so far, perhaps about the government commitments to net zero, or really how energy audits work, because Paul made a very valid point. Those energy audits, they are one way of identifying savings, energy savings that will then provide you carbon savings. And one thing we always see is, for example, the replacement of light bulbs. And you probably know those long fluorescent lamps you've got in your car parks very often. So you change them over to LED. That is very lucrative because it pays very quickly, and it will save carbon. So, for example, the auditing of light use within common parts is highly recommended. And then replacing old bulbs with LEDs will bring you carbon savings. So I'm just having an eye on the questions and chat, and there isn't anything. Let me check if there are any participants here. Yes, there are. We weren't alone over the last 15 minutes. So if there aren't any questions now, you can still note them down for yourself, and we can perhaps go through at the end. So I will now move on to the kind of hands-on practical section, what you actually could do, and also what you kind of need to do under the regulations, and then a few kind of best practice examples of where probably good building management would sit in terms of reducing carbon emissions. So Paul already alluded to it, and there is a challenge with decarbonizing heat. It is simply 90% of the heat is still generated by fossil fuel boilers, which require the input of natural gas, sometimes even still oil. Some of your older mansion blocks might still have oil tanks, which require replacement. And if we are a little bit systematic, how can we actually decarbonize heat? I've put it here on the slide as the first point. So where you improve your system efficiency, you will lower the input of gas, of electricity, or even of oil. And this then will lower your operational carbon emissions. So Paul already mentioned it. There's the difference between the embodied carbon that you cannot really change because it's within the building material, and it's the steel concrete of your big block. So that there's nothing you need to worry about. So you need to focus on the operational carbon, which is typically, it's measured in tons of CO2 per year. So that's good to know. That's the operational carbon you want to reduce to then kind of get in line with the government strategy to net zero. How you do it for heat? We've put on 8 steps over 3 slides here. The first 4, kind of they are about the building envelope and the outer building itself. And I put over a thermography on the left side of a building, as it was taken with a thermographic camera probably from an energy auditor. And it shows you kind of where there are red areas where heat is lost, where it's more green or yellow, the heat loss is less. And that, for example, is something to consider. So thermal insulation for roofs and external walls, as I put in point 1 here, that will save you heat. And then, as we discussed in our first point up here, you save heat, i.e. you save your energy, you will save operational carbon. Introduction of double or triple glazed windows will also save you heat, in particular against the some of the single glazed windows in older dimension blocks for existing blocks. Draft proofing and low air change rates are also important and are already delivered. For every one of you that takes care of modern buildings, of new apartment blocks that just have been built really in the last 10 years, in particular those 4 points, and in particular point 4, low thermal bridging, and even point 3, the low air change rates, they would have been delivered by design to a very good level. So what it means is the building envelope really for modern buildings is already highly thermally efficient, and existing blocks, all dimension blocks and so on, they are the ones that would require some more attention if you wanted to start saving heat and carbon, as we discussed. So that are the first 4 steps about the building envelope. Secondly, you would need to consider a replacement of your space and water heating system. And what it really means is introduce a new, more efficient gas boiler than you might have at the moment, or introduce heat pumps. And what a heat pump is, we can see one up here. So this is from one of the developments between, you can see the chart in the background. This development is between the Tower Bridge and the London City, the City Hall, I think it is. And that here is a large-scale heat pump, as it can be introduced into an apartment block. So here you can see it's just being hoisted during the construction process on the roof of the building. You can't see the building below, but that is something that the government repeatedly has been supporting. That's so-called heat pumps. If you want to make a note, there are air source heat pumps and there are ground source heat pumps, but heat pumps itself, as we highlighted down here, they are central to the government heat decarbonization strategy since 2013 already. So, and that means that can be heat pumps with refrigeration cycles. And what it really is, it is, for example, like you might have in your offices, that it's a outdoor unit, like a air conditioning, which has a kind of compressor outside, and then you have indoor cassettes to deliver your heating or cooling. So that is the same way a heat pump would work. So those heat pumps we are discussing, they can be with this refrigeration cycle where you have ceiling cassettes, or they come together with low carbon heat networks, which I will touch on later a little bit more, because you probably will have many of these low carbon heat networks, or as we refer to it as metering and billing company communal heating systems. So that's the same. It's just really the government term. They name them heat networks. So we said the heat source could be replaced to make it more efficient, or introducing a low carbon heat pump, low carbon communal heating system. Also controls are important. So that depends a little bit on building to building, whether you need radiator valves, whether you need timers. It is definitely a requirement to have a timer and a room thermostat under the building regulations part L. That is good to know. Also, insulation could be considered. You can see it over here. So this is now pipes as they come out of a communal heating system. You can see they are nice and shiny because they actually have been first insulated very well, and then they have been cladded with some aluminum to kind of protect the insulation. And this is kind of the picture we see here. Would be a distribution within a communal heating system, and it could obtain the heat from this heat pump we see up here, which is a low carbon form of heating, because it takes the electricity, as Paul mentioned, from wind farms, from solar panels across the country, which provide low carbon electricity. And what you can also consider when talking about central plant, whether you can optimize it. And that's point 6 is really applicable for new build. All those communal heating systems that you might be managing on behalf of the heat supplier, which is it's the freeholder or the RMC. They typically would require some form of optimization, as we have seen over the years. Moving on to the next slide. So our 8 steps, I think we've actually reduced them to 6 just because we condensed some of these steps. No, it is 8. It's just the formatting went wrong. So if you have, we can provide the slide or the slides for handout later. So that is point 7, and that's point 8. That just went wrong because it's a really brand new presentation we are pleased to give you today. So point 7 really is about energy management, and what it really means is just meter. Get your gas meter reads for your landlord supply. Get your electricity meter reads for your electricity landlord supply. I'd say almost every half year. That will be required to see how the building is currently performing and what really where the energy goes and where you then can save the carbon. There are also in-home displays that become more and more popular for inside the apartment. That's obviously a little bit out of your remit because it will be down to the owner occupier or the resident whether they want this sort of in-home display feedback. Thermostats really important. They are a no-brainer because what the thermostat really does, and we see one here on the left side, and a thermostat really just it regulates the temperature that the radiator puts into the room. And it sounds quite simple, but old valves wouldn't do this. If you have an old mentioned apartment block, you might just have a little 2-port valve, which it does not lower the heat that goes or comes out of the radiator when the temperature rises in the apartment. So that is almost no-brainer to fit thermostatic radiator valves, as we can see on the left side. And then usually you set it to number 3, which is around 20 to 21 degree, and that is all that is required to normally feel comfortable within the room. What is also a good point, and that is something really for you to remember, because I expect many of you will have communal heating systems to look after, the feedback through the billing, which is required now since 6 years. It's a requirement under the regulations to bill for heat networks or communal heating systems. That also does drive down the heat use. And ourselves, Data Energy, as a communal heat network metering and billing company, we see it all the time that once the first billing run to a new development goes out, it shows people just how much heat they consume. They will suddenly see kind of the price tag put against the last 3 or 4 months of heat use, and then they will start developing more reasonable use of energy and perhaps lower temperatures at the radiator valve, so to heat their apartments to a lower degree, or they perhaps use a little bit of less hot water where they want to save money. So feedback for billing shouldn't be underestimated. Also, point 6, try to broker utilities contract with a renewable share, and that's one of the points that I will pick up on the next slides. Let's have a quick look of what actually would need to be done first of all, in an existing building. So what we have here on the left side, that is a large apartment block in Portsmouth. I think it's called Wilmcote House for anybody that wants to look it up later on. And what is very interesting here, that the whole building was retrofitted to be almost as energy efficient as a new build. And how they did it really, they've applied this standard that Paul referred to earlier, this passive house standard, but they applied it to an existing building. It's called Fit standard, if you want to look it up later. And what it simply does for you as the property manager, it summarizes a lot of things that need to be done to make the building more efficient, to save your heat and then to save your carbon. Because what the standard would include is roof thermal insulation, it's external wall insulation, as we can see here on the slide. It's the introduction of double or triple glazing to draft proof, which is an important one. In particular, the old buildings we are talking about on this slide are usually very drafty. There's a lot of kind of cracks within the building, simply also between windows and window frames, doors and door frame. There's a lot of draft generated, usually in old buildings. And also the heating system was replaced. So that was all done under this Fit standard. We see this building here in Portsmouth, and they already had put in new windows, as you can see, and I think they were just about to put on external wall insulation. And the input kind of to use this, in this instance, this Fit standard, really that came from a external specialist, as I put here. So this is nothing for you to worry about. You would get in a typically an consulting engineer or a energy auditor that is experienced with thermal retrofits, and then they can draw up a list of what needs to be done for a particular building, because it might be different from building to building, and you might not necessarily want to do it to this high standard we see over here, this Fit standard, where they really, as I mentioned, they brought it from probably 1960s council block building performance. They brought it up to almost new, to very energy efficient performance. Important, and that's what I put down here. This sort of retrofit, and it can include external wall insulation and or even the premature replacement of a heating system, that will, as you can imagine, have high investment costs, and the payback times are quite low, which means that definitely will be considered a major works by the RMC and by the freeholder. So where you are asked to manage such a project, yeah, you need to put some budget aside. So within the service charge, I'd imagine that that obviously can become a more involved project than, for example, change LED light bulbs, what we mentioned earlier, which could be done probably even by your concierges for your car parks. So that's really one aspect. The decarbonization of heat requires a whole system approach. Now, that's now for new builds. We wanted to show you a few of carbon saving measures for new builds. And on this slide, as well as on the previous slide, I really want to pay attention that this is just a selection, and it will arrive from building to building. You really should ask your external specialist of what might be done best, if it requires external input. We've also put in 3 points now, which might be of very interest to you as the PM for a new building, as I imagine most of you manage new buildings. So those 3 points, this is what you can do. Point 1, try to broker gas utility contract with a biogas share, because biogas simply is produced typically from sewage and at large Thames water sewage plants, or sometimes also produced from as a mix of cow slurry and kind of crops that farmers or big farming kind of associations had left over. They put it in fermenters and create biogas. So the biogas is absolutely renewable and does not contribute to the climate change as much as your natural gas that you get from the North Sea or from the continent, that currently goes into your communal boilers. Actually, we can see a communal boiler over here. So many of you might be familiar with this picture. There's a communal boiler within a heat network, which at the moment still uses natural gas in I'd say 80% of developments that you will look after. So try to get a gas supplier with biogas. There are some I remember Crown, they do some biogas, or gas contracts. But just be mindful, currently the share of biogas in the UK is very low. So that won't decarbonize your building. You couldn't take an old leaky building where the heat escapes, as we discussed earlier, and then just supply it by biogas, because there's not sufficient biogas production at the moment in the UK to make this to stack up. In point 2, what you also can do, broken electricity contract with renewable electricity share, and that will be much more likely and much more achievable. As Paul mentioned earlier, there's a lot of wind farms that went up or everywhere in the North Sea that, as we speak, produce clean electricity. And what you can also do, point number 3, is when you structure the service charge for a new year, you could try to introduce an element for a reserve fund that takes care of the replacement of your heating system. So what we really want to say in this point here is that you could suggest to the RMC or to the Residents Association to start putting some money aside to introduce a low carbon heat pump, for example, for your communal heat network that you have. I've mentioned it earlier over here. This is the picture you might be used to, your big communal boiler plant room with a big gas boiler. This you want to kind of replace with a heat pump, and it requires quite a lot of considerations, even from consulting engineers, to how to tweak the system, because you also would need to optimize the system when you go for this modern form of heating, this low carbon heat pump. Something I put down here, this is always done by external specialists within your new building. It is worth doing heat network, or if you have cooling network, optimizations. So what you should be asking for here is heat network energy audits. And why this really is the reason is the modern day communal heating system isn't really as performing as designers thought it would be. And you will have noticed it perhaps many times when you walk into your corridors of the building you manage and corridors are overheating, or when the heat bills that go out to your residents are a little bit higher than expected, and therefore the system efficiency of the modern heat network is quite low. So ourselves, we've seen it over the last years that there are systems that can perform very well, but if your communal heating system was built between 2010 more or less and 2018, I'd say there's a chance it's not optimized and creates those issues that I just mentioned. And there you can ask for heat network energy audit, which will find solutions to address those problems and make residents happier. What you can also do, and that's usually, it's not too much of your remit, it's usually more for larger developments and for larger developers as well, where the developer is managing agent at the same time. They usually pursue quite ambitious low carbon building strategies for the future. So they would internally or externally would work out when to replace the current boiler, for example, with a heat pump, or how to amend this, as I just mentioned, this unoptimized heat network so you can introduce a heat pump. So that's something you could consider. Which brings me to the next section. So what we've done so far, we've really covered the things you could do. So kind of I'd almost say the scientifically correct things to do to get your heat use down. And as we then know, also to save operational carbon emissions. And now is a few words about the things that you need to do. And what we put together here is a little regulation overview. And again, I just want to pay attention to that. This is just a brief insight and wouldn't cover all the regulations that apply. So what we've provided here is a little we kind of systemized it a little bit to make it better understandable. We've put on 3 different categories of regulations that we see apply for heating systems and for the heat within buildings, and then also for the carbon emissions that originate from it. So I mentioned here there is considerable overlap between individual regulations. So this is really just a very brief introduction, and I'd be able to talk about regulations for low carbon heat networks, for air source heat pumps, and for for retrofits. I'd be able, or we would be able to probably talk about it in a 2 or 3 hours training course by itself, and because there's a breadth of it. And the first thing you should be mindful of is there is actual legislation in place to reduce carbon emissions. That's our category 1 I put on this slide. So in 2008, the UK government signed up to the Climate Change Act, which legally binds the UK to reduce carbon emissions. And that's exactly what Paul mentioned earlier. Now we have this net zero target at 2050. It originated in 2008 when the UK government said we need to reduce carbon from all sectors, from buildings, from transport, from manufacturing processes, from the power sector, the big power stations. This is when it was started, and it's legally binding. Also, in our second point here, local authorities would have had a high impact on the low carbon or carbon reduction legislation, because their planning requirements or also their planning guidance drove many heating system designers to install the communal heating systems as you can see them in your buildings. So in particular in London, but also cities like Manchester, Birmingham, because you might be connecting today from all across the country. In those cities, those communal heating systems, those modern ones, they went in because of the local authority planning requirements to put in low carbon communal heating systems, or as they would have called it, low carbon heat networks. A second group of legislation that is out there and is binding is the legislation on building energy performance. That's mainly guided by the building regulations 2010 Part L. You might have heard it. It's called Conservation of Fuel and Power. And there's loads of lower tier approved technical documents and technical compliance guides. That's all taken care of by building designers. So really nothing for you to worry about through the operation of the building. But this is where all the energy efficient design for modern buildings come from. It originates from the recommendation and statutory requirements given by the building regulations 2010 Part L. This is really guiding the thermal energy efficiency of a building. Also, there is this requirement to produce EPCs. Again, this is nothing for you to worry about, because if you look after a new build, a new residential apartment block, that would have been done by the developer, and they would have handed the EPCs or energy performance certificates. They would have given to you as the operator with the operation and maintenance manual. So to recap, our first kind of category was legislation in the UK about reducing carbon. Second, about improving the energy performance, which in turn will reduce the operational carbon, as we now know. And the third one is really any equipment specific regulation. And this list is very long, and we could extend it depending on the type of communal boiler you have, the type of heating system in general you have in your apartment block, or the type of communal heating system you have. One thing very important, as it might apply to many of you. So the heat network metering and building regulations was introduced in 2014, and it requires that apartment and block level heat meters are installed. So the reason behind is just to provide this piece of transparency for your residents that they are built on accurate use within their apartment. There's also lots of health and safety legislation, F-gas legislation, and so on. Those down here, they would always be adhered to by your maintenance contractor for your communal plant, for your boiler system or your heating system. So they are taken care of, and which brings me to our final section before we then start our questions. So how does it look if you want to do a reasonably good job, and if you want to save, let's say, more carbon than your neighbor building, in case you had some sort of kind of community internal carbon saving challenge. So how does best practice look like? How we do it well? So that is we'll be giving you now a number of kind of hands-on tips, and it directly leads on from the earlier point I say. Maintenance, or as you perhaps sometimes call it, servicing of central heating and cooling equipment is important, because simply speaking, regular servicing, as we put in bullet point 1 here, regular servicing of plant, heating and cooling distribution or heat interface units will provide this good basis that the system runs energy efficient. And as we now know, efficient systems will use less gas, get less electricity, and therefore use less carbon emissions. And the way you can compare it a little bit is really almost like with the requirement to bring in your car to a servicing visit and to change the oil, to change air filters and so on. Because if you wouldn't do it, your car would break down much earlier if you wouldn't regularly service it. And that's, you will be familiar, many of you, with the actual importance of regular servicing. But the tip we really want to give you is take care when selecting maintenance contractors for heat pumps and low carbon heat networks or communal heating systems, because not all of them might understand all the servicing tasks that are required. For later, you can go through down here. We've put a few standards here, and also over here that are photos from governing bodies for good standards and for good installations. You can go through them on your own time later. A second point, so first how to do it well was about how to service, who to contract really. Secondly, how does a good operation look like? And the way we condensed it for you here is really, and you can really make a note for yourself, one of the aspects of being able to reduce carbon eventually is to be able to meter and monitor the building. That's something that Paul introduced very early, and it's a very relevant aspect, not only among energy engineers and engineers themselves, but across all things in life really. As soon as you start metering, for example, the last year's gas use, and then looking at how much heat was spent at your apartment heat meters, then you will be able to tell what or how efficient the system was and how much carbon it emitted. And this is something for you to do. You could do so to ensure that landlords gas and landlords electricity meters are operational, and that you take meter reads, I'd say at least every half year, really for those monitoring and energy reduction purpose. Also, in our second point, to maintain apartment heat meters, because where energy meters are regularly maintained are actually functioning, that obviously will give accurate bills to the people. And I mentioned earlier, where bills are giving out to residents, that is typically has a high value as it saves energy. And also, as a very handy note down here, this is something brand new and not everybody of you might be aware of, but since November 2020, the heat networks, the heat network metering and billing regulations requires the heat supplier to maintain those apartment heat meters that I just mentioned. So really just maintain, they measure accurately and provide data for billing. And that is really now my last slide. So we talked about how good maintenance looks, how good operation looks, which really is just taking care of meter reads, what is within your remit, and now how good energy audits looks. And that's also Paul mentioned Energy audits are there to identify energy, carbon, and cost savings. And the minimum requirement really any energy audit should have is a easy understandable list of recommended energy and carbon conservation measures, also carbon saving measures. So this list typically comes in a table form that should be either worked out by you internally. If it's, for example, if it's a lighting audit, that might be quite easy to work out savings, or it should definitely be worked out by an external specialist. So what are the recommendations and which of them should be prioritized? So would it make sense to go for this very efficient EnerFit retrofit that I discussed earlier, which brings an old mansion block almost up to new build standards? Or is it just enough to just put on roof insulation, change windows? So the prioritization of your carbon and energy saving measures is should be part of any energy audit. And then kind of for later reference, considering the time, those items down here should be should also be addressed within the report. And we also provided you with a little summary slide here. This is for your later use, as we will be circulating the presentation in a handout form. And yeah, with this kind of overview and in-depth kind of hands-on tips, I'd like to thank you and open up the session for questions. I see there are some that came in, and perhaps I just going to read out the question, Paul, and we see whoever can address it. So there's one question here. There's one question from Nick, and he says, the big question, is there a commercially available and affordable air source heat pump which can recommend to leaseholders to replace gas-fired boilers and to be retrofitted? So air source heat pumps are not a new technology. I kind of alluded to it earlier. Old air conditioning systems would already work on the principle that air source heat pumps work on. So it's an external compressor that compresses refrigerant, which then it can go through pipelines to your indoor cassette, and it's a well understood technology. So I would say there is a whole range of air source heat pumps out there.
To be honest, Nick, there are many companies out there that supply them. Mitsubishi is one of the large ones. What you've got to do, though, is look at the property it's going in. I would not recommend putting an air source heat pump in to a property built in 1901, for example, unless you'd carried out a huge amount of improvements to the insulation within that building. Air source heat pumps run their radiators or the underfloor at a much lower temperature. So you have to have good insulation because you're only putting a lower temperature, say, into the radiators. Your gas boiler at home probably sends 70 degrees hot water to the radiators. An air source heat pump, it's going to be around 50 degrees. So that means you're either going to have to put in much bigger radiators to transfer that amount of heat, but you've also got to make sure that those rooms and those buildings are completely fully insulated. Otherwise, you'll just lose all the heat and you just won't get that room hot enough. So if you're going to go for an air source heat pump, you need to talk to a specialist who will come out and survey for you. They are out there. I know Mitsubishi are fitting, but if you look in the UK, there's not been many thousands fitted yet. But the Carbon Trust is pushing.
Yes, and we did see well-working air source heat pumps together with communal heating systems as well, where they in particular where they supplied underfloor heating systems, very efficient and low carbon system. In fact, the picture you saw earlier, that was from one system where the air source heat pump, the large central air source heat pump, was hoisted, and that was one system that fed underfloor heating systems, and it works very well. Moving on to your next question, Nick. So can you comment on how property managers need to be careful with improvement works, as the cost may not be fully recovered from leaseholder through the service charges?
With difficulty. Any improvement is obviously going to be a cost. You've got to weigh up the ones that will give you the best return on investment. The government's not yet announced any plans on how anything's going to be financed. There's nothing out there yet at the moment from government saying if you fit an air source heat pump, we'll give you X thousands of pounds, or if you carry out these insulation works, we'll give you this. There's been bits and pieces, there's been bits trickled through, yes, but there's nothing definite yet out there. So just keep your eye on the press, really, and what will come out.
Yeah, and I can fully understand you there, Nick. I mean, just recently with all the troubles you might got into managing those cladding issues that you might be aware of, where maybe external combustible cladding needs to be removed. That is a financial burden. So the service charge will already be very stretched. But one thing to bear in mind, for example, LED lighting upgrades usually pays back within a year. So that is almost a no-brainer. There might be companies out there that upgrade you the lights, and it's almost on a sort of on a sort of mortgage or lending money kind of principle. It's really the bigger ones that's the one you need to worry about, the energy efficient retrofit of wall insulation, external wall insulation. So moving on to next question. What would be at the top of the list to install or to update in an apartment block to improve energy efficiency? We don't really know whether this is for an old building or for a new building. So it is a very open question. Yeah. To be fair.
You need to carry out an audit really to find out what's applicable to your building. I mean, it can be simple things from TRVs on radiators make a big saving. Balancing your radiators makes a big saving. It depends on what the building is, what the supply, heat and energy supply is. So difficult to answer that one. If you want to come back to us with what the actual buildings are, yes, you're managing, we can answer directly. Yes. The next one. The block I manage needs the communal area lighting updated, including underground car park. Do you have any recommendations? I don't personally. I'm sure the company has, so we can look into that. And again, come back to you on that. If you want to email us, our emails are at the end of the presentation. Email us directly. We can put some information together for you.
Yeah, perhaps one tip. The replacement with LEDs is definitely always recommended, in particular when your car park maybe was installed in the early 2010s, where you still had fluorescent lights. But you need to manage the time those lamps are on. And yes, it's obviously safer to have the lights turned on 24/7, but there are well-working systems with motion detectors that turn on and off light as you walk through the car park, and that could be considered. But yeah, a lighting audit will bring actual recommendations to follow.
And finally, could you please explain the concept of feedback through billing?
Yes.
Is that literally increasing the prices to curb demand? No. What that is a heat meter, especially on a district heat network, stores a huge amount of information. Going back over 2 years, some of the better meters. You can read these meters every minute, every 5 minutes, every half an hour. They're normally only read once a day. But by reading them more often, you can see exactly what that apartment's doing when it comes to their heat and hot water usage. But you can also see when the unit's in standby and nothing's being used. So you can see if there's any anomalies there. So it might be a case of, this is a district heating scheme, you've got an HIU within that apartment, and it's got its radiators on. Now, a communal heating scheme, sorry to bore you to pants off you, but it's all about the return temperature. But if those radiators aren't balanced and set up right, the return temperature is too high, and that one apartment is having a direct effect on the optimization of that building.
Perhaps.
So it's very complicated.
And that's an excellent answer, really, from a technical point. So that is very applicable what Paul just said. But perhaps for you to summarize it, why is the concept of feedback for billing so important? It's simply over many decades, it has shown that once you bill people on actual reads, you get 10 to 15% of energy savings. And that really is only because the people, for example, if they waste a lot of energy within their apartment, they will get a high bill. and obviously they want to avoid paying too much. So they then will start asking themselves, do I need the room thermostat set to 30 degrees and the window open? Maybe it's unnecessary. So this is kind of where billing is important, and the metering, because it shows them how much they use, and also it will put a price value on it. So, and yeah, with this we answered all the questions.
Excellent.
Thank you. Yeah.
Well, thank you so much, Paul and Christian. Thank you so much. There's so much to cover, and I think it is another challenge for property managers to get their head around all of that legislation. And I think you've done a great job today. We'll be sending all the slides and information from you to all of the attendees today. So if they want to get in contact with you, there's no trouble doing that. We will be doing our next Knowledge Bank on the 25th of May, when Ibrahim Dalmir from Normanton Chambers and consultant Roger Southam will be discussing service charges, disputes and successful resolution with the case review. So if you haven't booked already, please go to News on the Block events and training to book your place. Once again, thank you so much, Paul and Christian, for your time today. And we look forward to seeing you all again soon. Thank you very much.
Thank you.
Thank you.
Bye-bye.
Thank you. Bye-bye.